Hello, grade 10. And so this is going to be our first topic for the fourth quarter. So last time I asked you to read what's on your textbook so that you can better understand my discussion. Okay? So now, let us recall the different states of matter. We have solid, liquid, and gas. We all know that these three states of matter have different particle arrangements. So as you can see, so we have here our solid, liquid, and gas. So the one at the left represents the particles of a solid object, and this at the middle is the liquid, and we have here at the right, which is the gaseous particles. So later we will be talking about this kinetic molecular theory of matter. But before, let us go back and recall the particulate nature of matter. Okay? So, hindi pala ito. So, sorry I did not prepare a PowerPoint because of time. Pero, ayan, I'm just going to upload this handout at a later time. Siguro after cards out. Ayan. So, now let's recall the different properties of gases. So, these properties are brought by the particulate nature of matter. So, let's go to the first one. So, we have here, gases have no definite shape and volume. So the reason for that one is because of the weak attractive force between the particles in a gas. As you can see in this and in this video, in this GIF. So the particles of a gas, let's focus at the one at the lower right. So they are far apart from each other. So the reason why they are far apart from each other is because of the weak molecular forces of attraction. Okay? So that's why they don't have a definite shape and volume. Yung liquids kasi natin, meron silang definite volume kasi mas attracted yung particles sa isa't isa compared sa compared sa gas. So next, gases diffuse rapidly. So each particle is moving constantly. So yun yung nakalagay din sa kinetic molecular theory of matter. So since each particle is moving constantly and compared to all of the particles, yan, as you can see here, so mas mabilis or mas mataas yung motion ng mga gaseous particles natin. So since they have a faster motion compared to solid and liquids, then they have a tendency to diffuse faster. Pag sinabi nating diffuse, yun yung, syempre, pag kunwari nagpabango ako dito, kapag nandun ka sa other side ng room, maaamoy mo siya kasi yung gaseous particles ng pabango ay yung scent pupunta din sa iyo. Okay? So, next, gases can be readily compressed. Dahil nga hiwa-hiwalay sila, pwede silang makompress kasi may empty space sa gitna nila. Okay? So, that's why kayang-kaya natin i-compress ang gases natin. And lastly, gases have densities much lower than those of liquids and gases. And again, the reason for this one is because of the large space, empty space between the particles of gas. So that's why they have low densities. Kaya nga dito sa mundo, di ba yung mas mababa yung density, yun yung nasa taas, kasi mas mataas yung density, yun yung nasa baba. Okay? So, kaya yung mga gases natin, usually kapag may bubbles tayo sa ilalim ng dagat, umaakyat siya kasi mas maliit yung density niya compared sa liquid. Kaya bubbles tend to rise. Okay? Ayan. So, ngayon, punta naman tayo sa kinetic molecular theory uli ng matter. Ayan. So, this one is focused on gases only. So, ayun na nga. Konting supplementary na lang dun sa sinabi ko kanina. Ayan. So, gases are composed of relatively far apart and distinct particles. So, syempre, nabanggit ko na kanina kung bakit sila magkakalayo. And we also have distinct particles. Like, we have oxygen particles, like, mapa-atom or mapa-molecule man yan para sa isang compound, distinct pa rin yung particles natin. So, second, gas particles are in constant random and straight line motion. So, kapag ang gases natin ay gumagalaw, random siya. So, walang nagde-define kung saan siya definitely pupunta. Pero, yung direction ay yung orientation kung paano siya gagalaw is laging straight line motion. Okay, so kita ba yun dito? Ayan. So, kumbaga kung napapansin nyo dito, straight line lang yung motion ng ating particles. Okay. So, wait lang. May papakita ako sa inyo. Ayan, ito na pala. Okay na pala. Ayan. So, so maglagay tayo ng mga gaseous particles dito. Ayan. So, pabilisin lang natin sila. Okay. So, kung napapansin nyo, yung direction kung saan papunta yung mga particles natin, iba-iba. Tapos, straight line motion lang sila kung paano gumalaw. Okay? So, yan. Tama lang. Ayan. So, ito yung parang, yan yung, ganyan, di ba nga naglagay tayo ng gas sa isang container? So, yung, as long as the gas is inside the container, it will always move in a straight line motion. And the only time that it's going to change its direction is when it collides at a surface. So, kung napapansin nyo, pag nagko-collide na sila sa surface, nag-iiba sila ng direction, pero straight line pa rin yung motion nila. Okay. So, yan. And next, so gas particles undergo perfectly elastic collision. So, pag sinabi natin, kung naalala nyo, pag sinabi kasi nating elastic collision, kumbaga pag after magkaroon ng collision ay merong nare-release or nako-convert na energy. So yung particle naglo-lose siya ng energy. So ng kinetic energy kaya tawag ito, ayan. Meron silang, yun yung ibig sabihin ng elastic collision. Okay, and lastly, the average kinetic energy of gas particles is directly proportional to the absolute temperature of the gas. So, kinetic energy is related to motion. So, the higher the kinetic energy, the faster the motion of the gas. So, kung napapansin nyo dito, di ba nagdagdag ako ng heat? So, ibig sabihin nun, ito, nakalagay in Kelvin yung ating temperature. So, kapag dinadagdagan natin to, ayan, tumataas. Kung napapansin nyo, tumataas yung temperature natin. Ano nangyayari sa particles natin? Bumibilis o bumabagal? Diba? Bumibilis sila. So, wait lang. Baka sumobra na yung pressure. Ayan, so, bumibilis sila ng bumibilis. So, kaya, ibig sabihin nito, mataas ang average kinetic energy ng mga particles na to. And at the same time, mataas din yung ating temperature. Absolute temperature ng gases natin. Okay? So, now let's go to the ideal gas versus the real gas. Okay. So, meron kasi tayong sinatawag na ideal gas and real gas. Both of them are made of small particles and kung baga napapansin nyo, ito lang din yung sa kinetic molecular theory natin, mostly empty space, low density, constant random straight line motion. So, doon magkapareho ang ideal gas at real gas. The only difference is these ones at the bottom. So, in an ideal gas, there is no attractive or repulsive force. So, kumbaga, the intermolecular forces of attraction are very negligible. Okay? So, kailan nga ba tayo nagkakaroon ng ideal gas? Kapag meron tayong ideal na conditions. Okay? Pero ayun nga, dahil mahirap tayo magkaroon ng ideal conditions, mostly meron tayo yung real gas. So, sa real gas naman, they have very small forces of attraction. So, di ba nga, nasabi ko kanina na in gases, there are relatively weak intermolecular attractive forces. Pero meron. So, kumbaga, yung properties ng real gas, medyo malapit na siya sa ideal gas. Pero yun nga, meron pa rin siyang small forces. Pero ang ideal gas kasi wala talagang attractive or repulsive forces. Okay? Yun. So, kumbaga malapit-lapit na si real gas sa ideal gas. And so, it also, ideal gas have so there is no volume for the particles in an ideal gas, but for the real gas, they have a very small volume. And then for the ideal gas, collisions are elastic. In real gas naman, the particles will actually lose energy when they collide. Ayan. So, so yung sinasabi lang dito, yun yung pinagkaiba ng ideal tsaka real gas. Okay. So, dagdag ko na lang din. Ito. Ayan. So, ayan. Ideal gas is one with negligible molecular volume and with molecules that are relatively far apart, resulting in negligible attraction. Ayan. So, pero yun nga, under extremely high pressures and extremely low temperatures, so kailangan kasi nasa extreme na conditions yung real gas para mag-act siya na as an ideal gas. So, kaya meron tayong tinatawag na standard STP, standard temperature and pressure. Ayan. So, yun yung tawag dito. Yun yung time na yung real gas ay malapit-lapit na sa properties ng ideal gases. So, kumbaga, pag ang real gas ay na-undergo sa STP or standard temperature and pressure, and so they will act closer to the properties of an ideal gas. Okay? So, yun lang yung ano natin. Pero yun, yung i-discuss natin after, we'll act as if na may ideal gas tayo. Okay? So, ito naman, yung gas laws natin. Ayan. Pero before tayo mag-proceed dyan, let's talk about pressure. Ayan. So, gases also exert pressure. So, for example, if you blow a balloon, di ba, you're putting air inside the balloon. So, bakit siya lumalaki? Kasi yung gas particles na nasa loob ng balloon ay nag-exert ng pressure dun sa dun sa gilid or dun sa loob, sa sides ng container, which is the balloon. And since a balloon is stretchable, so nag-give in siya dun sa pressure at nag-expand siya. Okay, so kaya meron tayong pressure kumbaga merong pressure na ina-exert yung gases natin kasi nga napupush niya yung sides ng container para mag-expand yung balloon. So that is one of the evidences that you can say that pressure is exerted by gas particles. Okay? So, iyon. Okay? So, ngayon, punta tayo sa different gas laws natin. So, ayan. Okay. So, ngayon, proceed na tayo sa different gas laws. So, meron tayong tatlo na basic, tapos meron tayong pinagsama. Okay? So, yan. Usually, ang tinitignan natin sa gas laws ay 4 na quantities. So, those are namely volume, pressure, temperature, and amount of gas. So, ito yung mga different na tawag dito. Yeah. Different units natin for volume, pressure, and temperature. Kasi for amount of gas, moles lang yung gagamitin natin. So for volume, we have your 1 ml equals 1 cubic centimeter or 1 liter equals 1 cubic decimeter or 1 cubic meter is equal to 1,000 liters. Ito naman pressure, we have 1 atmosphere equals 760 millimeters mercury. Kaya siya 760 millimeters mercury kasi meron tayong experiment. Ayan. So, yung picture niya nasa textbook nyo. Tignan nyo na lang. Dito, meron kasi silang dinevise na contraption na may mercury sa loob. And meron siyang tower sa gitna. So, tas may open area. So, syempre, nag-exert ng pressure yung gas doon sa open area. So, yung 760 millimeters na yan, so yan yung, kumbaga yan yung inangat na level ng mercury dun sa pressure na ina-exert ng gas. So kaya meron tayong unit na 760 millimeters mercury. So ito meron tayong 760 torr. So ito meron tayong equal din siya sa 101,325 pascals. And that is also equal to 14.6956 psi. Pero for this case, we will mostly use atmosphere. In volume, we will use milliliters or liter. And then for temperature, we will mostly focus on degrees Celsius and Kelvin. Pero ayun na, mas gagamitin natin yung Kelvin scale dito. So dapat tandaan nyo kung paano mag-convert ng degrees Celsius to Kelvin, which is mag-a-add lang kayo ng 273.15. Okay. So, yan. Punta na tayo sa first gas law, which is Boyle's law. So, at constant temperature, the volume of the gas is inversely proportional to its pressure. So, ito yung kanyang formula. So, P1 V1 equals P2 V2. So, yung 1, yun yung mga initial condition. Yung 2, yung final conditions natin. So, sinasabi natin na kapag tumaas yung pressure, liliit naman yung volume. Okay, so an example for that one is squeezing a hollow rubber ball. Yan, so, ayan, it decreases the volume of the gas. And kumbaga, pag mas lumiit yung surface, yung volume, tawag dito, mas mag-i-increase yung collision. So, parang ganito. So, kunwari, tawag dito, ayan, liliitan natin yung volume. So, galawin natin to. Ay, wait lang. So, syempre, reset na muna natin. Ayan. So, taasan natin to. So, pataasin lang natin, pabilisin lang natin ng konti ang ating particles. Medyo mabagal sila. So, sinasabi lang dito na kapag ito, mas malaki yung ating volume, tingnan natin yung number of collisions in 20 picoseconds. So, we have approximately 114 collisions. But if we compress this one or paliitin natin yung volume, tignan natin yung number of collisions. Kasi yung number of collisions, yun yung pwedeng maging basehan natin sa pressure. Okay, so let's see how many collisions you will have if we have a smaller volume. Kanina 114, di ba? Ayan, so ngayon, niliitan natin yung volume, 180 yung collisions. As you can see, naging 35.3 atmosphere yung pressure nung niliitan natin yung volume. Okay, pero nung nilakihan natin, yan, so naging 19.8. Kumbaga, inversely proportional nga sila sa isa't isa. Okay? Next. So, yung tawag dito, yung computation part, siguro sa Monday na lang natin i-discuss. So, concepts muna tayo ngayon. Okay. So, pag nag-synchronous na lang tayo. Okay. So, next is we have Charles' law. So, Charles' law states that at constant pressure, the volume of the gas is directly proportional to its temperature. So, we have V1 over T1 equals V2 over T2. So, ayan. Ayan. Ito kasi mga sasabihin ko sa inyo pag PowerPoint yung meron tayo. So, one example is, yun nga, yung chilled sandwich sa 7-Eleven. So, di ba lang siya flat? Pero kapag yung lalagyan niya, hindi binuksan, tapos nilagay na sa microwave, di ba usually babalik sa inyo na nakalobo na yung plastic. Kasi, ang nangyayari doon, kapag naiinitan yung isang gas, nag-e-expand siya. So, tawag dito, at constant pressure, the volume of the gas is directly proportional to its temperature. So, lumalaki yung volume na inoccupy ng gas whenever there is a higher temperature. Bakit? Kasi nga, meron tayong increased motion of particles because of the increase in temperature. And so, since hindi naman constant yung volume natin at constant lang yung pressure, so para makarelease siya ng, para hindi magbago yung pressure, kailangan lumaki yung, tawag dito, yung volume ng gas. Okay? So, balikan natin ang ating, so, ano yan? Constant, wait lang. Maglagay muna tayo ng gas. At constant pressure, yan. At constant pressure, tama ba? Constant, wait lang. At constant pressure, the volume of the gas is ito, yan. So, yan. Liitan natin. Okay, huwag na tayo dito. Okay, so yun na. At constant pressure, anong dapat dito nga tayo? Constant yung pressure. Ayan. Kung napapansin nyo, ayan. Kapag mas malaki, yan, 325 Kelvin. So, mas malaki. Pero kapag niliitan natin, so mas lumiit din yung, kasi constant yung pressure natin at 5.8 atmosphere. So, kapag mas maliit siya, ayan. So, kumbaga, para hindi magbago yung pressure na nararanasan ng container, kailangan bumaba yung temperature. So kapag lumaki, para hindi kunwari hindi nagbago yung pressure, kailangan tumaas yung temperature niya. Ayan. So yun yung ating Charles law. Okay? So ngayon punta naman tayo sa Gay-Lussac's law. So the Gay-Lussac's law states that at constant volume, the pressure exerted by gas is directly proportional to its temperature. So, ang example niyan is yung pressure cooker. So, meron naman siguro kayong pressure cooker or alam niyo naman kung ano yung pressure cooker kahit na wala kayong ganun sa bahay. So, yung volume kasi niya, constant. Kasi, di ba, nakakulong lahat sa loob ng pressure cooker. So, yung liquid doon, syempre, kapag inaglagay ka ng heat, syempre, magluluto ka, di ba? So, nag-change na siya from liquid to gas. So, yung gas, nasa loob lang siya kasi nga nakakulong lahat dun sa loob ng pressure cooker. Since the volume is constant, hindi nagbabago, pero continuous pa rin na nadadagdagan ng temperature. So, ibig sabihin nun, pabilis ng pabilis yung ating particle sa loob. So, ang nangyayari dyan, yung increased kinetic energy, and increases inside the container, thus the pressure exerted becomes higher kasi nga mas bumibilis at mas tumataas yung number of collisions natin kapag mas mabilis yung yung particles natin. So kaya mabilis makaluto at nakakapagpalambot ng karne ang pressure cooker kasi gawa nung Gay-Lussac's law. So tignan naman natin ngayon sa ating simulation kung paano siya gumagana. Okay? So, ano nga yun? Constant volume. Okay, so gawin natin yan. Constant ang volume. So, titignan natin kung ano mangyayari sa pressure tsaka sa temperature. So, dagdagan natin ang yan. So, kung napapansin nyo, 479 Kelvin, naging 9.5 atmosphere. So, kung pabababain naman natin, bumababa din yung pressure. Kasi naka-base nga siya sa number of collisions natin. So, tingnan natin. Yan. So, at 298 Kelvin, and tingnan natin yung number of collisions at 10 picoseconds. We have 38 collisions. So, kaya mas mababa yung pressure. Taasan natin ng konti. Gawin natin Yan, 623. So let's look at the number of collisions. And again, the volume is constant. Hindi natin nilalakihan or nililiitan yung container. So we have 45 collisions. And as you can see, as we increase the temperature, the pressure also increases. Okay? Yan. So, yan lang yung ating tatlong basic laws. Yan. So, ngayon, yung problem solving, huwag mo ng problemahin yan. Okay. So, meron tayong tinatawag na combined gas law. So, yung sa combined gas law naman, doon pinagsama-sama yung relationship ng pressure, volume, and temperature. And assuming na meron tayong constant number of particles of gas. So, amount of gas natin ay constant. Okay, so i-discuss ko na lang to sa Monday, yung problem solving. And ito, meron din tayong tinatawag na ideal gas law. So yung ideal gas law naman is for, meron kasing relationship na nakita sa standard temperature and pressure. So meron tayong tinatawag na universal gas constant R. Kailangan yung memorizing ang value nito, which is 0.08206 liters atmosphere per mole Kelvin. Ayan. So, ayan. So, kung napapansin nyo, tawag dito, ayan. So, I'll end the class here. Mas gusto ko kasi na kausap kayo kapag tayo ay tawag dito, ay yan, yung computation part. Okay, so, ewan ko, screenshot nyo na lang yung mga questions. Pero i-discuss ko din naman yun on Monday. Okay? So, yun lang. See you next meeting. Goodbye!